Good afternoon, Ben Holken, Senior Lecturer in Mechanical and Mechatronic Engineering, part of the Centre for Audio Acoustics and Vibration, and I'm back here in the Vibration Lab at UTS Tech Lab, and this video today is about particularly using properly the Kinetic Systems ELpF benchtop anti-vibration table, which you can see here, and which we have mounted onto the top of that at the moment, the MSA-050 scanning laser vibrometer sensor head and test stand. And so this video is not particularly about the vibrometer, but actually focusing on the anti-vibration table which sits here. I'll just go to the cabinet to show you where the video, for the sake of the video, where the manual comes from. So we've got documents in the lab, and if you're in any doubt about what the equipment is that we have here, then please refer to these documents. Also, we assume, of course, that you've been properly trained on how to use the equipment, you've booked the equipment in the lab booking system, and you've completed a project risk management plan. Assuming all of that to be the case, I draw your attention particularly to this video to this manual, whereby I should inform you that we have the 01 version, which is a £100 capacity of the load on the table itself. So if whatever it is that you want to use on this anti-vibration table is over £100, and obviously you would need to convert that into kilograms if necessary, then please do not use this system. It won't have the required capacity. What we need with this anti-vibration table, how it works, is essentially we have bladders inside, and they're quite sensitive and delicate. To provide pressurized air to those bladders, which we will set up shortly in the video, we need to connect to an air supply. There may be a laboratory air supply where you're working, but we've also recently acquired a benchtop quiet compressor system, which is powered via the normal GPO, general purpose outlet, and has a pressure regulator on here to allow us to know how much pressure is in the cylinder. It also has a tap which we can rotate once we've connected our device, which I'll do so with this quick release here. So we connect like so, and there is a pressure regulating system here. So once we've turned this one on via this tap, you can ignore this tube that's just sitting here in case we want to wire anything up later. This tap turns on. This is how much pressure maximum we have available, which is 100 psi, and the system requires, as you would have seen in the manual, maximum line pressure of 80 psi, or at least I should say at 80 psi we get 100 pounds capacity. So we can adjust this screw to give us 80 psi line pressure, so clockwise more pressure, anti-clockwise less pressure, and that's our gauge that tells us we've got 80 psi. Since we're over here at the moment, when we come to want to disconnect this from our compressor, these are the steps that we must take. We turn the tap off, we release the pressure in this side of the system by pressing this car-type shader valve underneath, and then we can pull the quick release back, and we make sure that we've got one hand near to this connector. If we remove this when it's pressurized, then that can be quite dangerous. This can get launched across the lab into test sample, or hurting or injuring a person, and that's not what we want. Okay, so that's connecting, and then we need to power it up. So we turn this to auto, because this pressure system here is maintained even in the absence of, or in the event that we remove some air from here to power our system, and you'll hear it when you're using it. It's very quiet, which is great. It doesn't vibrate very much, which is great, obviously, for the sensitive measurements that we make in the vibration lab. So we're now connected. We've got positive pressure here to our anti-vibration table, and we use this pressure regulator here to get pressure from our line into the bladders within the system. And you can see as I gently increase this, and the compressor just kicked in there, you won't be able to hear it, but it's now putting more pressure in. As I rotate this gently, please do not over tighten this, we will see that eventually, if I get enough pressure in this, then my sample starts to rise up. And so the pressure here is clearly a function of how much mass I have on the top of the table. And it will rise up at the front first. You will maybe notice that it's coming up at the back later. Okay? And eventually it will kind of come up, and it will start to stabilize and settle into a horizontal orientation. The compressor's just gone off. Now the distribution of the mass on the tabletop, i.e. where is the centre of mass relative to the table, and the 4 bladders in each corner that control the position, is adjusted using these screws on the side. So we can either increase or decrease the pressure at one side by adjusting these. There are 3 of these, so these behave like a tripod, and there's one over at this side which we can release and increase, and there's one at the rear to allow us to adjust, which you won't perhaps quite see, but the rear one I can reduce or increase the pressure. All right, and so it's important that if you move the sample or add significant mass to the top with your test piece, and this is quite heavy, but for the sake of, and I haven't tried this yet, but for the sake of demonstration, you'll see that this sank slightly, and therefore, the mass distribution's changed. Sitting down a little bit at the back, we can give it a bit more pressure here, and as long as what we have on the top is still not over that 100-pound limit for 80 psi of pressure, we'll have it nicely, essentially sitting suspended on a bed of air, if you like, on a series of pillows of air, and therefore any vibration from the floor is isolated from getting into the test piece, which is sitting above. And please take care of this equipment. We only have one. If you don't know how to use it, please ask. And I hope that's a useful video and you can use it to get good data and good measurements. Thank you.